Hello, welcome to my channel Code Design. Today's object-oriented design is designing a call center. As you can see, the smiling lady is talking to her customer, and it's a picture of a call center. However, this is a AI generated picture. So let's see what we will be covering today. So we will be first understanding the requirement. We'll make some assumptions about requirement of call center. We will identify classes and attributes and functions and their relationships, how the classes relate to each other. That's part of the design, and then we will deep dive on the coding and how we'll see how the functions were implemented. Now, as the nature of this design is a multi-threaded system, because there is a call dispatching and customer is waiting, putting them on the queue. So basically, it's a multi-threading system, and we need to understand how multi-threading was handled and thread safety was ensured. We will do that, and finally, we'll run the program and analyze our output. So let's move on to the requirement. We have our requirement here. We have basically three level of employees in call center. We have operator, we have supervisor, and we have director. So we can assume that the operator can get the initial calls, and the operator can handle the call. If the operator can handle the call is marked completed. If not, the call is escalated to a supervisor. Now, if supervisor cannot handle the call is escalated to a director. And director must be able to handle the call. He cannot escalate to anyone. So that is the flow, basically the call flow. Now, if a call is intended to a level and no one on that level is available, that means if a call is for a supervisor and no supervisor is available to take the call is queued on the respective call queue. That means the queue for supervisor. And there is some extra credit requirement. So I think this is good for any interview. But I was curious to do something more. So thread safety we will be discussing and implementing, keeping the ability so that a customer can connect to a supervisor or director is keeping lower levels. So what does it mean? That mean we always don't have to go through operator, supervisor, and director these sequence. Because from my personal experience, when I had to talk with some company people, and there was a situation, then I needed to talk to a supervisor. And what I had to do, I had to always go through the operator, then supervisor to talk, and that was a lots of wait time. So, wouldn't it be nice to directly get to the supervisor with some code that will direct me direct to a supervisor and implement functionality that will check all call queues after certain interval and assign call to an employee based on employee level. So, this is actually very important. So if employee is not able to receive the call gets to the call queue. Now we need to have some kind of scheduler, right? So that it checks after certain interval that if there is any call waiting, and then assign a respective employee to receive the call. So now, as part of the design, let's first identify the classes that we will need. So as we can see, our first main class is call center, which is our system, and we have calls, we have caller, we have employee, and as I say, there are three type of employee we are considering: operator, supervisor, and director. And now we'll have a look on the classes, not detailed implementation. As I say, detailed implementation and code type will be later. So let's see the caller. So caller has a caller ID, and we have a issue related to that the caller is concerned. And for keeping simplicity, I kept it here if issue resolved instead of creating a different class for issue and then assign it to caller or related to caller. So, because issue tracking is not our focus at this moment. So, and here, a issue, we can set a issue by the setter method, and there is a method is issue resolved because we'll need this method to test this system. As since there is no human here to deal with this, so we have to generate something, some randomness here to return a Boolean value which will indicate if a issue is resolved or not. Then let's go to the call. So our call class has call state, and we are having three type of call state: ready, in progress, and complete. So initially, when initially a call will have the ready state, and when it is assigned to some employee, the state will be changed to in progress, and when issue is resolved, the call will be marked as completed. Now, there is a employee rank here associated with the call, which is basically the minimal rank of employee who can handle this call. So in our case, it is operator, but as I said, we can have it to supervisor or director even if we want. And the call has caller. The call should be having a handler. So this handler will be changed as the call can be escalated, and when it is escalated, a different type of employee will be handling the call. So we have a function here, set handler, to set the call handler, which is setting employee. And this is how our call class constructor looks like. It will take a call, and it will take a employee rank for the initial destination. And initially, we will assign the call state as ready. Now let's go to the employee class. So I kept the employee as an abstract class. Um, uh, why abstract class? The employee, all the employees mostly have all similar functionality, but there is only one functionality that is actually different from operator to supervisor to director, which is escalate. So operator will be escalating to supervisor, and supervisor will escalating to director, and director has no one to escalate. So he has to resolve the issue. So that's why this method is abstract. Otherwise, all the methods here can be shared between all the employees. So the rank I have kept it inside employee class because it's the employee rank and it's an enum. And so employee will have employee ID, employee name, rank, and current call. So employee should have track of the current call that is assigned to him or her, and the call center object. So employee belongs to a call center, and this is free, which indicating if employee is free and ready to assign a call. So what are the other functions we have? We have receive call, we have complete call, we have is free. So and we have assign new call, set free, and we have process call. So that's it, employee. And let's go to a specific type of employee. So operator extends employee. Um, Operator is inheriting employee, and here we set the rank of the operator by calling the constructor of the superclass employee. For supervisor, this rank will be supervisor and everything will be same. And for director, this rank will be director. Everything is same, but this, of course, this escalate call will be different for different type of employee that I have mentioned. And then our main class call center, what our call center should have. Call center should have call queues. So what happen if we have three operator and we have 30 calls? So the calls has to go to the queue, and the call queue, since we have calls for different rank of employees, so it makes sense to keep the call queue associated with the employee rank. So here I'm using a hash map for the call queues, concurrent hash map, and for employees also I am using a hash map which will hold list of employees based on rank. And it could be also list of list, so instead of map, but in that case we have to remember that index 0 is operator, index 1 is supervisor, and index 2 is director. So I thought instead of using list of list, it is more readable to use map of list, which is our map of queues of call. Why we need this queue data structure? Because the first one who calls should be picked up first. So that's why we maintain the queue. And what else? Let's see the constructor for this call center. So this, as I say, the call center will have employees. So this is where we are associating employee with call center. While creating the call center object, we will be passing list of operators, list of supervisors, and list of directors, and we can pass the call center name. So in an office, there could be actually a couple of call centers because each department can have a call center. Say, for an example, American Water, if we consider American Water. So American Water also has some services for electricity, some services for other thing, electricity, some insurance, and other services. So then the department is separate, right? So the all the issues with water will go to water, and issues with electricity will go to electricity. So this design will actually help you to create multiple call center and maintain them in a single program. Then you need another driver program or a driver program that will create multiple objects of call centers. So here we are creating some empty list, linked list, and putting it on the hash map based on the rank. So for operator, we are putting a list. For supervisor, we are putting a list, and for director. And this is one important thing where I had to think that this call center and employee is getting tightly coupled because, as I said, a call center has employees, and employees belongs to a call center. So that means employee needs call center as a parameter, and call center needs employee as a parameter. So it is tightly coupled. So how do you create object? How do fast call center or fast employee? So in order to solve this, what I have done, um, for employee object, while we create employee object, I'm not passing any call center, but it has a variable call center instance variable. But we don't need it during the creation of an employee. So later on, when we are passing these employees to a call center, then actually we are looking through each of the employee list and associating them with this call center. So you can see set call center o dot set call center. That means employee dot set call center, operator dot set call center. These supervisor dot set call center. These. So we are associating all the employees with their respective call center, and for this case, this call center. And okay, so there is another thing, scheduling assigning call from queue. So we can come here later. Let's look at the functions that we have in our call center. We have add call to queue. We have handle call, we have dispatch call, we have find available employee, and we have check availability and assign. So only these two method, add call to queue and handle call is public, and the rest are private method, cause dispatch call is being called inside handle call, and we also and this check and availability, right? So this find available employee is also called inside handle call. So we will look at the implementation details. Okay, here is the implementation, and for implementation we will switch back to IntelliJ, which will be easier to read. So let's go back to our call center, sorry, our call class. And what we can see, we have the set handler, where a employee we are associating with this call, and the rest is same. And let's go to caller. So for caller, this is the randomness we have is result. We are creating a random object here, and this is thread safe, thread local random, because we are doing this in multi-threaded environment. So it is just getting an X double and checking if it is less than zero point 0.5. So this is how a different call will get different value, true or false. Is result true or is result false, and based on that, call will be escalated or completed. And then we can see the employee class here, and let's look at the methods here. Public method here, receive call. So and so on the receive call, what we are doing, we are synchronizing here, making this block thread safe, because we have here a current call, and we are setting up the state of current call, which is shared among threads. And also um, we are as long as a receive call is called, we are setting the employee set free false, because the employee is not engaged, already received calls, to ensure that no one is able to pick up this employee and for another call. And call handler. So call handler is the employee. So we are assigning it to these employee. And for this employee current call is the call that the employee receives, and the call state will be changed from ready to in progress, because it is now in progress. Then there is a function process call. What we are doing in process call, we are basically doing nothing in process call, but we are creating some pause here, sleep here, to simulate that the employee is talking to a customer and trying to resolve. While you are doing it, we will be running this application at the end, and to simulate the employee is talking to a customer, we have this process call. After process call, we'll check if the issue is resolved. So remember, we had the function is issue resolved in the call, and in we have this in the caller actually. Sorry. So if issue is resolved, we will call complete call. Otherwise, we will change the call state to ready and escalate the call to the next level. And if there is a um, so here we are actually catching some exceptions for director, because if this employee is a director, he should not be able to escalate call, so he will get this exception, unsupported operation exceptions. So the control will come here, and then we'll have to complete the call here, because a director cannot escalate a call. Let's see what we have in complete call. So in complete call, we are changing the state, call state from in progress to complete, and we are printing some log, and set issue resolved, right? Cause the call is complete, so we are setting the issue as resolved, and also making the employee free so that he is available for next call. So is free. Is free, how is free is implemented? Current call, right? If employee's current call equals null, then employee is free. But this is not actually enough. Initially, I thought this is enough, and on object-oriented perspective, actually it should be enough. Current call equals null. But since we are using multi-threading, actually the thread doesn't wait for this current call to set up null. It picks up the same employee for all 5 or all 7 calls while I was testing. So what is the solution? Solution is to use another variable is free. And as long as we find a employee available before we assign, we need to make set free false. I will show it. And assign call calls a receive call, as the function says assign call. So assign you call even understand that what is the purpose of this one. And so that's it for employee. So let's go to our special employees. So operator, let's see how the escalate call is designed here. So current call dot rank, right? So when escalating, so a operator should escalate the call to his supervisor, or to a supervisor actually. So we are setting the minimal rank to handle this call to supervisor and putting it on the queue. So it will be picked up by a supervisor who is free to take the call. So this is how we are putting the call in the queue. Call center dot add call to queue. And once we are putting this call to the queue, we are setting the employee free. So here is another functionality that we could implement, notify all supervisor, because since the call is put on a supervisor queue, we could notify all the supervisors that there is a call waiting in the queue. So let's go now and see supervisor. So for supervisor escalate call, the next level is director. So supervisor will escalate call to director and do the same thing. After assigning the call rank to director, it will put the call in the queue, and we can notify all director. And finally, we have director here. And that's what I have mentioned earlier, that the requirement is director is the highest level of employee, and a director cannot escalate a call. He has to handle the call. So that's what exception we are throwing, saying that director cannot escalate call. They must be able to handle calls. What else? We have went through caller, we have went through call and employees. I think now is the time for the call center. So we have seen earlier how the constructor is working, but there was one thing here, scheduler dot schedule schedule at fixed rate, and we are providing the assign call from queue. What is assign call from queue? This is a function. So we are passing a function. We are first assigning this check availability and assign function to a runnable variable, runnable type of variable, and then passing this runnable in this scheduler, passing this function and saying initial delay 5 seconds, and it will the scheduler will call this function assign call from queue. This function after 10 seconds of intervals. So this is our scheduler, which is a fixed thread pool. For a small system, one thread is good enough. But if we our call center is very big, we'll have multiple thread. We can just change the number of thread in the thread pool. It's basically a thread pool. So let's go and see add call to queue. Um, so we are using a lock here, a reentrant lock. So initially I used synchronization here, then I had a deadlock issue and I had tough time to find out where it is having the deadlock. Though I didn't have to go through the thread dump, I could do it. I actually look at the code and found the code looks good. But there is a thing with synchronization. Synchronization sometimes hit deadlock, so it's better to use reagent lock than synchronization when you have little bit complex things. But for simple things, right? Like I have used in the employee classes, most of the time I have used synchronization. Synchronous block, that is fine. It's doing only a few line or few things. But here in this at basically I was having issues in this one check availability and assign. But since in this class I am using a lock, so I did not wanted to use a mix of lock and synchronization block in the same class, which could be even creating another problem, because synchronization block will try to take a log of this object, and log works differently. So it's better to use same kind of locking mechanism in same class. So add call to queue. Um, uh, so it so see in this add call to queue, we are not passing the rank because call has the minimal rank that can handle the call. So from the hash map call queues, and from the hash map call queues, we are getting a call queue for a respective operator. If this rank is a operator, so we'll get the call queue for operator. And what share basically in multiple thread for this function, it is call queues. So call queues is shared among so many functions and different classes. That's why we had to had it within logs. So we are getting the call queue, and we are adding the call in the queue. So it will be add at the end of the queue, because queue is a fast in fast out data structure, and we are printing the queue size. So you can relate it when you call to some busy place, and they will say that you are on waiting list or waiting number 18, 5, 6, 10. Your waiting number is 10. So we can give this kind of information, or we can notify caller this kind of information based on the queue size. Because since we added the customer right on the queue, so there will be queue size minus one people waiting before him or her in the queue. If it is an IVR system, we need to generate a voice message and drop it on the IVR call for the customer. Now we can look at the handle call. This handle call is very important because this is in this class call center, we have only two public method, add call to queue and handle call. Rest are private methods. So, and why this handle call is important? Because we need this dispatch call in a thread. If we don't do, if we don't create a new thread and call dispatch here, the call will be blocked here. That means though you have so many operators or supervisors waiting to receive the call, but it will be sequential. All the threads will be stuck here on the dispatch call. So that's why we need to create it on a defined thread. And you should remember any kind of dispatch, wherever you do any kind of dispatching, actually you should create a new thread and then call dispatching. There's the norms. Otherwise, it will be a sequential program. And what it does, it find available employee for the rank. And when it find the available employee, it dispatch is called the dispatch call with the call and the employee. And here what we can see, this is the employee optional. So that means if it is null, we should not be getting any error. With optional, we should be able to check if employee is present. We can see it on the next function. So here is our dispatch call. You can see we had a call, dispatch call with the employee optional. So employee optional here. So what we are doing, we are checking if present or else. So that means if employee is present. If employee is present, what we will do? We will basically assign a new call to this employee, and we can print some log. And what for the else part, if the employee is not present. If the employee is not present, we will be adding the call to the queue. And as you can see, this part we need thread safety, because we are adding the call to the queue and we are printing some status here that could be vulnerable to threads if we don't do it. So find available employee. Um, what we can see here, with the rank, for a rank we get all the employee list from the employee map, and then we can use the stream here and filter by is free. and then find fast. So we want the fast employee in the list that we can assign a call. And if employee is present, again, it's optional. So we are checking if employee is present, and if employee is present, the first thing we need to do is employee.setFree equals false. So this is the place where I was stuck, and I was having issues because the same employee Bob was getting assigned by all the call was getting assigned to trying to get assigned to Bob. So Bob was very busy and all the employee was free. So the first thing I had to do here, set the employee free false, so that if multiple thread call these things, they should not be able to pick up Bob. Only one thread will be able to pick up him. So now this is the important function, check availability and assign. So this is the scheduler. The scheduler call these things. So for call queues, what it is doing, for each rank, it is getting call queues and checking if call queue is empty. If not, call queue is not empty. So then by rank, it is getting all the employees of a rank. And so this is our rank and this is our call queue. So employees, and it is looking through the employees and again checking if call queue is not empty and employee is free. Then it is pulling or taking one call from the queue and assigning it to an employee. So since it is taking a call from the queue, then the queue could be empty, right? So that's why it is checking if the call queue is empty. If the call queue is empty, it is breaking the loop. Because if there is no call waiting for, say, a rank operator, there is no call waiting for operator, then it doesn't make sense to loop through all hundreds of operators. It will be just wastage. So this is what important here. And what are the things here shared within threads is call queue and all employees. So that's why I had to put them within lock and unlock. Also, this is important, check availability and assign. If multiple thread get the chance to enter here, this block, then again, one employee like Bob will be shared within multiple threads and in the same time. So now that I think that's it, but now we need to test our call center. And to test this class, we have this call center test, and we are creating here four operators and adding it to the list of operator. We are creating two supervisor. We are creating two director and the call center. As I said that it is possible to create multiple call center instances and handle them. Create multiple employees and assign the employees to different call center, but one employee should not be assigned to multiple call center. That's the thing we need to maintain. Here we are creating only one call center. We are naming it Verizon Wireless, and we are passing the operators, supervisors, and directors for associated to this call center. Then we are calling handle call. What we are doing in handle call, we are creating new call, and within new call, we are actually passing new caller. So we are passing the caller ID 1, 2, 3, 4, 5, and all of them is operator. So we are passing 5 operator. So as I said, there is some extra credit. We wanted to we wanted this system to be able to assign a call directly to a higher level of employee like supervisor or director, and that's what we'll be testing. We have a supervisor. We have a call here intended to go intended for a supervisor, and we have a call here. Caller ID 7 intended for director. So let's see what happens when we run this. Okay, it is running, and let's analyze the output. Placing call with caller ID 1, which is the operator, Bob. Um, so call with caller ID 1, it is trying to place to Bob. Caller ID 2, it is trying to place to Alex, and 3, it is trying to place to Tom, and 4, Tina. So these are all operators it is trying, but we have actually called 5 and 6. So since this is multi-threading, so the output will not be coming sequentially. So now we can see caller ID 6. It is going to Adam, which is Adam is a supervisor, and caller ID 7 is going to employee John, who is a director. So which is expected. And we can see now call 5. So call 5, since we have 4 operator and 5 calls for intended to operator, so we have to add it to the queue. There is no way. So adding call to queue, call 5 is added to the queue for operator, and the queue size for operator is now 1. Checking call queue for rank. So this is the scheduler that is checking queue. So what it found one call in for operator, no call for supervisor, no call for director. And now we can see that supervisor queue size is 1. Why? I think one of the call is processed by operator and it now came to supervisor. Call 3 assigns to employee Tom. So as I said, it is now starting to assign call. Director cannot escalate call. So well, the call went to director. It again got the random function and said the issue is not resolved, and it tried to escalate the call and got one exception that director cannot escalate call. They must be able to handle calls, which is expected. We are catching the exceptions, that's why the exceptions look good. And so queue size for supervisor is now 2. Call 4 is assigned to employee operator, completed with caller ID 1. Okay, so now we can see the calls are getting completed. Call 1 is completed, and call 2 is completed, call 6 is completed, 7 is completed. And what you can see, call 6 is completed. Okay, it was for supervisor level. Call 7 is for director level is completed. And here we have call 3 is completed. It was assigned to operator, but it went up to supervisor. That's what you can see during completion time. It went to supervisor. Similarly, call 4 went to supervisor level because the operator wasn't able to resolve the call. And finally, we have call completed for caller ID 5, which was also operator, but it went all the way to director John, and John resolved it. So how many? 4, 5, 6, 7. Yeah, we had actually 7. And now you can see the scheduler is checking the call queues, and all the call queues are empty because we had all 7 calls, and all call queues are empty. So I think that's it. I will have the a GitHub link as a comment on the video, and my website link that I was showing, or so you should be able to go and see the codes from there. There is some description. You should be able to get the code from GitHub repository. So let me know if you like this, or if you have any question, or you didn't like it.